Okay, so for the domain and range of this relation, starting with the domain, it's going to be all the x values. This solid circle means we include this point. This open circle means we go right up to it but don't include it. Every point on this graph has an x value that starts at -6 and continues until we get up to +8. So it's everything from -6 to +8, but just not including this. So here's the domain. We can write it as an interval, -6 to 8, just not including 8. Now the range is going to be all of the y values. So the lowest points on this graph are here at y is equal to 2. And we get all the y values that go up. We go past this point up until we get to 11. And we do not include 11. All the y values go from 2 up to and not including 11. So there's our domain and range. Now, is this thing a function? A function has to pass the vertical line test. All this is really saying is that if you choose a point on the graph, you can't have another one above it or below it. And every point on this graph never has one above it or below it. There's never a repeated point. So this is, in fact, a function. So this is a function as a question, and the answer is yes. The goal for this one is to solve a linear inequality, and that is 2x plus 5 is greater than or equal to 0.5x minus 4. So we're going to start by figuring out where these two graphs meet. That would have to be this point of intersection. Now, I know that the red line represents 2x plus 5 because the y-intercept is 5 and the slope is 2, whereas 0.5x minus 4 refers to this blue line because the y-intercept is -4 and the slope is clearly 1/2. If we were to figure out where these two meet, that's a very easy equation to solve. Essentially solve this thing for x. I think I will subtract 0.5x from both sides, as well as subtract 5. And when I do this, I get that 1.5x is equal to -9. And now I divide both sides by 1.5. And my answer is x is equal to negative. So that's going to be 3/2, get -6. That makes sense. Here's -6, and here's where the two graphs meet. So I'm going to mark that on here. This is the intersection point. It appears at -6. Okay, now to solve the inequality, there's no more actual work that we're going to write out. It's just looking at this picture. Where is the red graph greater than the blue graph? So I'm going to actually mark that on here that it's this portion of the graph. This is where 2x plus 5 is greater than 0.5x minus 4. So I'm actually referring to this portion of the graph. And it's our job to write down what are the corresponding x values for this. They start at -6 and clearly go in this direction. So the answer to the question is x is greater than or equal to -6, or you could use this interval to write your answer too. So it was a two-step process. Figure out where the two graphs meet. It was at -6. I solved it down here. And then using the graph, which side of -6 are we choosing? We chose the right side. For this question, I'm going to define my variable x to be the liters of 80% acid that we're adding. I'm now going to use this variable to set up an equation. One side of my equation is going to be what I'm mixing together, and the other side is what I end up with. Okay, so on the left side of my equation, I'm mixing two solutions, so I should have two separate pieces, and it's always a percent times an amount. We're taking something that is 30% acid, so we have 30% times 2 liters, and I'm going to add into that some number of liters of an 80% solution. So that's how much acid we're actually mixing together. I want this to equal something that is 75% acid. So on the other side of my equation, I only want one term. It's going to be a percent times an amount. The percent that I want is 75%, and the amount of stuff that's going to be in the solution is going to be the 2 liters that we start with, plus however much we pour in from the other solution. So this side is what I mixed together. Each term is always a percent times an amount. On the other side is what we end up with. There's just one term because there's just one solution, and it's a percent times an amount. What I'd like to do now is solve this thing for x. So I'll have to distribute the 0.75, combine some like terms. Let's see what we get. This is going to be 0.6 plus 0.8x is equal to, if I distribute the 0.75, I get 1.5 plus 0.75x. So I'm going to subtract 0.6 from both sides, as well as subtract 0.75x from both sides. If I do this, I end up with 0.05x is equal to 0.9. I now want to divide both sides by 0.05. Okay, so I move the decimal, that's 9 divided by a half, that's going to be 18. So x is equal to 18, and that is 18 liters that we have to mix in. And our goal was to increase the concentration of acid, so our answer makes sense. Question 4, I'd like to sketch a couple of transformations. Both of these have 2 different steps to them. I'm going to actually write down what they are, and they should both be able to fit within this picture. So for this first one, 0.5 times f of x minus 4, it's a 2-step process. If I follow order of operations, I work within the parentheses first and then deal with this 0.5 outside of the function. So I'm first going to subtract 4 from the x's. This is going to be the opposite, where I'm not going left 4, I'm going to go right 4. My second step is to multiply by 0.5, and that's going to take half of my y values. So just a couple of notes to myself. What I can do now is take these 3 points, run them through those 2 steps. I should get a graph that at least resembles the thing that I start with here. Okay, so first, I'm going to go right 4 places. The y value is 0, and if you take half of 0, it stays 0, and that's my very first point. So far, so good. Okay, this one, I'm going to go right 4 places. The y value is currently 6, and if I take half of it, it drops down to 3. So 6, 3 is the second point. Lastly, I'm going to go 4 places to the right. The y value is 4. If I take half of it, it goes down to 2. So I end up at 8, 2. I know what my final graph is. It is this. The whole thing moved right 4 places, and then we took half of the y values. For the second one here, again, this is also just 2 steps. Okay, I see we're multiplying the x by 2. That does not double the x's. In fact, we're going to take half of the x's. Let's put half x's. Now this -1 outside the function is our second step. This means we're going to multiply our y values by -1. What this is going to do is reflect over the x-axis. And the note I write to myself here is just to say I'm going to reflect the y's. I'm essentially just multiplying the y value by -1. All right, so let's start here. Step 1 would be to take half of the x value. The x value is currently -4, so it's going to go to -2. Now I multiply the y value by -1, but the y value is 0, so it stays right where it is. This is -2, 0. Let's repeat that for this point. The x value is currently 2. If I take half of it, it goes to 1. The y value is currently 6, and if I multiply that by -1, it goes to -6. So we're at 1, -6. And lastly, okay, the x value here is 4. Taking half of it goes to 2. The y value is currently 4, and that means if I multiply by -1, it goes to -4. So we end up here. and this is my graph. I took half of the x values and then reflected the y values over the x-axis, so both these fit in my diagram, and that's it. All right, to solve this absolute value inequality, I'm going to do most of this work on my graphing calculator. I'm not requiring that you draw a graph, but what we do need to figure out is where do these two things equal each other? Now, the method we came up with is, if I first want to solve where they're equal, I'm just going to ignore the absolute value and just try to solve this. But also, it could be that I leave one of them alone and take the negative of the second equation. This is another way that the absolute value could actually equal, is if you leave one alone and make the other negative, because in absolute value, it would cancel as negative, meaning the two things would still be the same. I'm going to solve both of these equations separately. The one on the left, I'm going to add x to both sides and also subtract 1. And this leaves me with 3x is equal to 3. That's pretty simple, actually. We get that after dividing both sides by 3. X is equal to 1. Now, on the other equation, I'll distribute the negative. I get 2x plus 1 is equal to negative 4 plus x. You could actually start here if you wanted to. Like, obviously, if you distribute the negative, it just changes the signs on everything on the right. I'm now going to subtract x and subtract 1 from both sides. So I'll take x away as well as 1. And I get x is equal to negative 5. So those are my two solutions. The next thing I'm going to do is go to my graphing calculator, and in place of y1, I'll put the absolute value of 2x plus 1. In place of y2, I'm going to put in the absolute value of 4 minus x. I'll try to sketch what I see on my screen, but really you can do this directly in your calculator. You should see 2 points where the graphs intersect, and then I want to check to see where is this graph greater than this one. Where's this blue function above the green one? So I'll try that now on my calculator. Okay, so here I sketched what I saw on my graphing calculator. I put this in place of y1. I got a graph that went like this. Y2 gave me this graph here. I checked to see that both my solutions were correct in my table, and they were. It might be nice to sketch this if you'd like, but I mean, I really think you can answer this just by looking at your actual screen. That's fine. Where is the blue graph greater than the green graph? And there's only two options. It's either between these two values, or it's on the outside of those two values. That is it. There's no third option. And in fact, it's going to be everything outside of these two values. Here, I have y1. It's definitely above y2. Over here, y1 is definitely above y2. This is saying we're on the outside of those two numbers. If you check in between these two numbers, notice that the green graph is above the blue graph, so I do not want this. So I can actually see in my picture that, oh, I'm referring to this portion of the graph and this portion of the graph, which is referring to these x values. I'm now ready to write my answer. You can write it in a couple of different ways. You could say, oh, well, x would have to be less than negative 5, or we could take x is greater than 1. Both of those places work. If you'd like to use intervals, that's fine too. You could say negative infinity to negative 5, put a union symbol, and then say 1 to infinity. That would be okay as well. And either way you choose to write it, that's the answer. So for question 6, the ultimate goal is to solve this inequality by using a graph. And this is not going to be as difficult as it seems. Step 1 is going to be to solve this equation, go to your graphing calculator and graph the equation, plot where the solutions appear, and then use the graph to figure out where we're either greater than or, in this case, less than 0. So starting with A, I say you could use factoring or a quadratic formula. This one factors very easily, so that's what I'm going to do. We should be able to set this up as the product of two linear terms. It has to be a positive and a negative. All right. I want two numbers that multiply to negative 6 yet add to negative 5. And those two numbers would have to be a positive 1 and a negative 6. This times this is negative 6, yet if you add the middle terms, you would get negative 5. And once I see that this is how it factors, I can simply look and say, oh, well, if I put -1 in place of x, it makes this factor 0, so the whole thing is 0. Likewise, if I look here and say, if I put x is equal to +6 in place of x, this factor becomes 0, meaning the whole equation would equal 0. I'm going to now graph this equation and hopefully see these two solutions appearing on my screen. Okay, I do. Again, this does not have to be a perfect sketch, but at -1, it definitely is equal to 0. And at +6, it's equal to 0 as well. And the rest is just a quadratic that goes between these 2 points. It disappears off the screen, but I'll try to just sketch in what I see. Goes down to this point, crosses over. Technically it disappeared, but I know it comes back up, and then goes through that point here. So the sketch doesn't have to be perfect. All we need to know is where's the graph above or lower than 0. So here's part C. Where is the graph less than 0? So here is 0, and I know where it is equal. To be less than 0 means I'm below this line, which is referring to this portion of the graph. So I'm going to go ahead and shade that in. This is where x squared minus 5x minus 6 is less than 0. It is your job to identify what are the x values. Again, it's a situation where it's either got to be between these two values or on the outside of these two values. Clearly, it's going to be everything from -1 to 6, and that is the answer. The answer is we go from -1, we can go up to 6, and that is it. I won't put an equal sign because there's no equal sign that appears here. So the answers that you get in part A should show up in some way in part C. All right, so for question 7, we're trying to figure out the domain of a given composition. And a good starting point would be to first identify what's the domain of both the functions f and g. If you look at the function f and you want to know its domain, it's actually all real numbers. Or you could put, from -infinity to +infinity. Nothing goes wrong here. You can put any number you want in place of x, multiply by 4, add 2, and there are no issues. When I say something goes wrong, we're either looking for dividing by 0 or perhaps something with like a negative number under a square root. If you check out the function g, there is a fraction. There's exactly one number that makes the denominator equal 0. I'm hoping to set it up so at least in this part the answer is obvious, but the number that makes the denominator 0 is -6. So the domain is any value for x except -6. If you put -6 here, you get -6 plus 6, that's 0, that's a problem, but every other number is completely okay. So I think just a couple of notes here is like f of x, everything works. G of x, I just can't use -6, and then we can move on. So part B is now to actually get formulas for what happens if we compose these two functions. Let's start with f composed with g of x. What this says is take the function g and plug it in place of x. Wherever you see an x, you're going to replace it with 1 divided by x plus 6. I see this as put 1 over x plus 6 right here. So f of g of x is relatively simple. It's the function f, but wherever I see x, I instead write 1 over x plus 6. And that's it. You could try to simplify this further. I say leave it here. Now for g composed with f of x, so this is going to be backwards from what we did, where this time I start with the function g, and wherever I see an x, I put 4x plus 2. The function f is going in place of g. I'm going to put 4x plus 2 right there. 1 divided by, I see x, I put 4x plus 2, and then plus 6. This one I think is probably easy enough to simplify in the denominator where g of f of x is equal to 1 divided by, it's really 4x plus 8. So I think that one's simple enough to take it one step further, but that's all I'm looking for. Okay, part C is find the domains of the compositions from part B. And this should be simple enough to just look at the formula and say, do you think there's a number that won't work here? F of g of x is actually pretty obvious. The number that doesn't work is -6. So I'm going to start there. F of g of x What's the domain? I can't use -6. If you think about it, before we even get the formula, you'd have to put -6 in place of x here, but that number can't even go in place of g. And because of that, I can see it in the formula as well. -6 is a problem, but everything else is okay. This is my answer. Whereas if you look at g of f of x, it might be okay to put -6 into this function. And the reason is, you would first put -6 in place of f. F's going to take it to probably a different number, and that number can go in place of g. So let's check this out. There is one number that you cannot put in place of x, but it's not -6. It's the number that makes the denominator equal to 0. I think I set this one up where it's, again, easy enough to guess. 4x, it can't be -8. So what number makes 4x -8? -2. X cannot be -2. The reason is, if you put -2 here, it would make this -8. And -8 plus 8 is 0, and you can't divide by 0.